In this video, let's discuss the relationship between the sample coefficient beta, so the coefficient that we find based on the regression line that we fit, and the population coefficient, to see what's the difference between them. So the population coefficient would be the actual effect of education on wage if we have information about every person on this planet, so literally the population. And again, the population might differ from the question we solve. Maybe that's just going to be the effect of education on wage for people in Netherlands or in Germany and so on. So the population has to be specific to what we are researching. Now, still, no matter what the population is, it's pretty much impossible to have data to every person. That's why we always take random samples to estimate. So this head shows us that this is an estimate of what's happening in the entire population. But because they are not equal, and that's something to keep in mind, they are not equal, they are just an estimate. So the sample coefficient is an estimate of the population coefficient. What we can say though is that in expectation, in the long run, in expectation, the expected value of our sample coefficient is equal to the population coefficient. What does that mean? That means that if we take very many random samples with people and plot the relationship of education and wage, on average we're going to have most coefficients from those samples equal to the population coefficients. And if we plot them on a graph, then we would have a normal distribution. So if we plot them on a graph to show this relationship on a graph, this is how it would look like. This would be the distribution of the sample coefficient beta, and it would be a normal distribution around the population coefficient. So it would be around the population coefficient, meaning that, again, most observations of the coefficient would be the actual population coefficient, the actual value that we're interested in. But there's gonna be deviations, there's gonna be observations where we are further from the beta, either to the right side or to the left side. So that's the intuition of this expected value. It's about what's happening if we randomize samples very many times and see what's the trend, what's the pattern. And the pattern is that we are going to be around the actual population coefficient. One more thing that we have to keep in mind is because we don't have this equation holding, because beta of the sample is not equal to the beta of the population, what we're interested in, as always in statistics, is the confidence interval. So what would be the confidence interval of the population parameter beta? So the confidence interval, let's say we're speaking about the 95% confidence interval, because that's usually the most common one. The confidence interval of the population coefficient beta, well, that's showing us a range of values. That's going to show us the range of values. So we will have the sample coefficient plus minus a margin of error, which is going to be the critical value z at the 95% confidence interval, multiplied with the standard error of this sample coefficient. And what does this show us? And let's write that down because this is really important. That shows us a range of values, for the coefficient beta, so for the population coefficient beta, that will be included in 95% of random samples. So in other words, if we take very many samples, random samples, and we draw confidence intervals around that sample coefficient, in 95% of the cases, in 95 of those confidence intervals out of 100, we will have included the actual population coefficient. So in 95% of those random samples that we would draw from the entire population, we would have the population coefficient in reality. And in those 5%, we would not have it. And that's okay, because statistics is never about being 100% certain. There's always a probability of error. And those 5% that we are missing, that's what it shows us. There is a chance that the confidence interval that we are drawing does not include. It misses out the coefficient from the population. I hope this makes sense, and we are done.